questions from the public before we go on to the recap? Any and all questions? We can do a recap first. All right. So first, we have this viz we wanted to show you. I think it is super exciting because I didn't have to write it. Let me switch over to it and try to share it.
Are you going to try and share your screen?
Yeah, but I already fucked up.
I mean,
some random
watch an expert hacker use learn how to use Discord.
Gamer, man, this is for gamers.
Dude, you cut your teeth writing like MUDs and stuff, so I think there's a clear line for you from gamer to hacker.
That's where DEF CON should have gone. All right, hold on. I managed to. One sec.
Is it not letting you share the screen?
No, that's not the problem. I have
other redact all of the information on the screen.
Yeah, fair enough. We didn't think about this. We didn't think this through all the way, but I'm almost there.
So I guess I can talk a little bit. Does anybody out here have no idea what CTF is or how CTF works? Or are you all CTFers who are trying to look for hints?
Well, probably if they are here and don't know that, they probably don't want to speak up and say, hey, I'm a noob. Although we're all noobs, especially Adam.
Yeah, that's definitely true. So welcome, everyone. We're the Order of the Overflow. We run DEF CON CTF. There's a lot of CTFs at DEF CON, but this one is ours. So we basically, the idea is we have qualification events usually in the May timeframe. And so last year, I think we had 1,700 teams from around the world that competed in our qualification event, and the top 16 teams were usually invited to come to Las Vegas to compete head-to-head in a CTF. And so there's basically two different types of capture the flag events. So the qualification event we run in May is a Jeopardy style CTF, which you can check out one of our scoreboards. Let me actually. Oh, I don't even think I can share, man. I'm trying to vamp for you, but. So I will drop this in CTF discussion text. So this is a link to our scoreboard from 2020. So that game ran straight for 48 hours. And we started with no challenge opened and opened up challenges kind of slowly over time. And so then from there, the top teams, you can check out the scoreboard. I mean, it's crazy how good these teams are and how many challenges they solve. So the top 16 teams here, along with some pre-qualification events we have, they were invited to compete in the final event. And so Jeopardy style CTFs just kind of have challenges, and the idea is everyone's attacking the same service. So a challenge will have some intentional vulnerability. Maybe it's a website, maybe it's a custom binary service. But the idea is that as organizers, we write something that has one vulnerability, and that's maybe a super cool way of exploiting something. And then the team and players have to identify that vulnerability and exploit it in order to steal a flag. So that's where the whole notion of capture the flag comes from. And this is different from attack defense CTFs, which is what Jan's going to talk about in a second, where basically the idea is all the teams are essentially running, you can think of virtual machines that are identical, and they're each running the same vulnerable services that we wrote. So it's not like these are again custom services. It's not like we took an old version of bind or something that has a vulnerability and you can just run nmap and metasploit against it. I mean, these are custom pieces of software that the teams have to analyze, identify for vulnerabilities, and then launch exploits at all the other teams to steal their flag, and then they give the flag to us, and then we give them points. So that's kind of the rundown at the high level. You want to jump in?
The high level, exactly. There's actually two types of challenges we have in our game. One is this type where you steal flags from each other. The other is called King of the Hill. It was invented sometime in the mid-2010s in Japan, and has been adopted in other competitions, including ours. The idea is that competitors try to beat each other in terms of the optimality of their approach. This makes sense from an algorithmic perspective, right? If you want to write a faster sort algorithm, you can imagine a sort algorithm competition. Was the same with hacking. Right now, we have a King of the Hill challenge running. We'll talk about that is a Las Vegas blackjack casino with a crazy twist. So, as I mentioned, this is what I'm streaming right now is the quals board. It's a little chaotic. We had a whole bunch of challenges that the teams really attacked. The scoreboard really drives this home. Basically, this is the qualifying round. So the top N teams of this, along with winners.
Ugly emojis. What is this? Linux?
Yeah, man, this is what you should do.
Is this what happens when you live in the Linux life?
Oh yeah, exactly. You see how I do this?
Good Apple emojis, man.
Yeah. Anyways, Linux hating aside, all hackers run Linux, by the way. It's true. The top team here solved, like, I don't know, I can't even count this with my level of sleep deprivation, but a lot of challenges, right? And these are tricky. We have had challenges in the past that teams have burned real, like, 0-day vulnerabilities worth real deal money to kind of shortcut, right? So it's pretty cool stuff. This is what our game looks like right now. So let me refresh this, and we'll just kind of go from the beginning. Oh, thank God, that server's still up. All right, so we started in tick 1, of course, at about 4 a.m., 5 a.m. this morning, Vegas time. Nothing happened for a while, and then Casino Life started getting solutions. Casino Life is a blackjack simulator written using a computing environment developed in Conway's Game of Life. It is a really crazy thing. We can't talk too much in depth because the challenge is still going. It's still active. We'll talk about it when it goes down in the next public recap after that. But you can see teams started kind of pulling away from each other in Game of Life. So you see people that are really good at the casino, people are bad at the casino. And then you just saw what is basically PPP, a very famous heavy-hitting team in the scene, pull ahead temporarily because they started exploiting a different challenge that we released called Rorschach. Rorschach is a machine learning challenge. None of the endpoints are accessible right now, are they, Adam?
Say that again?
Not with my setup. All right. Adam, do you want to... you can't share your screen, right? It's not working?
I haven't enabled it yet. I have to give it, as security people, we always say the best thing you should just do is give an application all of the permissions that it requests of you. So let me type in my password and give, an application like Discord the permission to record my screen, which there's absolutely no way that could ever go wrong. But I do need to quit Discord and reboot it to get back. So
actually, Adam, do you see my screen?
Yes, I can see. Okay. No, I can see the browser window, so I can see.
Yeah, Antonio is a massive noob. It's okay.
All right. From the Twitch stream can't see it, but you know what? You're on Discord. Discord's where it's at. This is where DEF CON's happening. So I'll be right back.
This is where DEF CON is happening. All right. So 3 challenges. I'll talk about 2 of them because they've been solved to a point where at least I can talk about them at a high level. Casino, I already mentioned, blackjack game and Game of Life. The other one is Rorschach. It's a machine learning challenge. So in recent years, the field of machine learning security has skyrocketed in importance. One of the things that I personally wanted to accomplish in our tenure as the host of DEF CON CTF is the creation of a real category of machine learning challenges in Capture the Flag. I started this out on our first qualifiers. I had 2 machine learning challenges, one called Atom Tune, where players had to create impersonations of Adam, who just left to restart Discord. And then the other challenge was Flaxifier, where players had to perform what is called a training set inference attack. They were given a trained model, and they were needed to recover the types of images that were used to train the model. So the model would recognize, in this case, images of letters, and then they would figure it out. Hey, nice. The next year, last year, at finals, I created a challenge called AI Han Solo, where which was an attack defense version of this training set inference attack, where teams had to tweak their models to make them unattackable. This year, I created Rorschach, which is a slightly different twist on ML Challenge. I'll talk about it when it is. And the artificial brain, it turns out, is extremely foolable, and has been several years of research now showing just how fucked we are as a society relying on these things, right? So you have examples of where people can slap a sticker on something and a stop sign, and it'll get misclassified as a not a stop sign.
Can y'all see my screen? So I can talk about Casino Life. I just pulled it up.
Oh, brilliant! All right, yeah, I can see it.
Cool, awesome. So yeah, so this is a challenge created by one of the Overflow members, Casino Life. And obviously this isn't the challenge itself. This is a visualization of the game. So one of the cool things, we can go back to an earlier round, like round 13, and it will play. And so the interesting thing, as you're seeing this, you can see that there's a number of players at this table. And wow, you can see that there's a lot of people who, even if you don't know blackjack, they're very bad at blackjack. So lost, push, lost, right? All these people did really, really poorly at blackjack. And so if you wonder, well, why are they so bad at blackjack? Well, we can actually see there's a nice link in here to the dealer's brain. So let's go look at the dealer's brain. Can y'all see this? Can I get a thumbs up, Jan, or something? Okay, I can't see. Okay, cool. So this is now, so what we're looking at here, this is actually, we started this, and I'm not going to give too much away, so I'm not going to go into this, but this should be very familiar with people who played our qualification event, because there was a challenge where teams got access to something that looks very similar to this, and what they discovered was people had to have implemented a CPU entirely in Conway's Game of Life. So if you're not familiar with the Game of Life, it's how would you describe it? Actually, I can make something up, but I don't know if that's the most accurate way.
No, yeah. So the Game of Life was this exercise basically in the most interesting physical simulation you could create with the minimum amount of rules. So the Game of Life basically has 2 rules. One is when a square dies, and the other one is when a square is born. And from that, just by iterating through, you can create complex concepts. The idea was,
right now I'm going through, Jan, and I'm showing kind of some examples from the Google search of, oh, there we go. There's a GIF. Nice. So you can see kind of things moving, and it has this appearance of life, like complex behaviors emerge from very simple patterns.
Exactly. And then kind of to add some history to this challenge, direct history. A couple years ago, there was a Stack Overflow challenge, and the code called Stack Overflow, to create Tetris in the Game of Life. So people have implemented some cool stuff in Game of Life. They've implemented, these little like glider things, which are like little guys that just fly forward, self-propagating. They've created shooters, which are guns, generators that create gliders. They've created a bunch of different stuff. And this Code Golf challenge challenged them to create Tetris. And this was possible because some crazy people have created logic gates in Game of Life.
And that's all we need, as we've seen time and time again in crazy, weird machines that come up in Magic the Gathering games, in Minecraft, all kinds of stuff you can build. So kind of, I mean, I honestly don't know very little about this challenge because I did not design it, but you can kind of see in the lower left region here a bunch of things of what looks essentially like memory, right? You have what looks like kind of that pattern that you would expect of like physical bits memory. And essentially, people figured out all the things that you need to represent things to mimic a digital circuit. So you can see there's like buses through the system where bits can go from one place to the other, just like they do on the actual physical chips of silicon that are running in your system. You have memory units, so they'll store either a 1 or a 0. And again, the crazy thing is, remember, I think it's something like, I don't know if Eric's on this call, but something like each dot in here, this like green or red or blue thing.
2048 by 2048 pixels. Each pixel.
Each pixel in this image, yes, exactly, is 2000 by 2000 Game of Life thing. And so they different things represent ones, different things represent zeros, different things can move in and out. It's all a very cool way of representing this, and really kind of thinking about computing at a very basic level and trying to understand a machine really from the ground up. And so now that we know that that's what the dealer's brain is, essentially then you can think what's happening here is the teams are not playing blackjack directly. They're uploading something to do with this Game of Life, and that it is playing blackjack. So let's then go. So we just looked at the earlier rounds where we can really see that everyone's just doing terrible, right? Like none of these bots understand the rules of blackjack. They don't understand. They just keep hitting, which is if you've ever played blackjack, just don't hit all the time. That's a very bad one. One player got lucky, player 9, and got blackjack here. But besides that, they did not do very well. So if we go towards one of the later rounds, like just round 75, hopefully we'll see that the teams are actually doing better here. So cards are coming out. Dealer has an 11. That's not great. 14. Dealer hits on soft 14. Dealer, oh man, dealer got 21. So nothing we could do. They all lost. But the other interesting thing is we can see that all the players bet different amounts of money, so that the players are actually writing bots in this Game of Life logic that understand this, that understand blackjack and can essentially play it. So that's kind of where we are with that challenge.
The Game of Life concept here, of course, at an abstract level, and it's a game of blackjack, but it is kind of the latest in this long line of genre of CTF challenges based on esoteric platforms. The idea with these esoteric platforms is to try to distill the concept of what makes a let's say a reverse engineer at their core a good reverse engineer. Is it familiarity with a given architecture? Is it the fact that some reverse engineers that I know can look at x86 assembly and they're more comfortable with it than with the C code, right? Or is it some deeper way that their mind works? If we pull them out of x86 and we put them into Game of Life, and suddenly there's a different computer that they have to understand, or a different grader system, because Adam pointed out this hardware, right? It's not just software, it's a whole hardware machine that they must understand. Will those skills carry through? The mission of DEF CON CTF is to identify the best, fastest, most adaptable, etc. hackers, and this is one of these routes toward that potential identification. For qualifiers, we introduced teams to this concept of a Game of Life as a computing platform with 2 challenges. The second one I'll talk about was really crazy. It was called Lifebox Adventure, and actually, let me pull it up on our archive where you can go and play.
I'll do that while you talk, Jan. You can do. I'll do.
Okay, awesome. So look at game console implemented in Game of Life. So I mentioned the original challenge that led on the Code Golf Stack Overflow that led to the creation of this computing environment inside Game of Life was for Tetris. This takes a kind of a step further.
That's
What's
funny.
up?
Nothing. Keep going.
All right. This takes it a little step further and implements a game console with controllers and with Adam. Your stream ended.
Yep, I know.
Okay. Do you want me to stream archive?
No, I'm spawning a server real quick to see if that works. Just a second.
Oh, okay.
Just keep going.
So, the game console challenge from Qualls had a boot loader that did verification like a real game console on the cartridge, and et cetera, et cetera, et cetera, and would load a game and play it. And in order to solve this challenge, the top team, the only team to solve this challenge, they created in Game of Life a mod chip, a hardware mod chip created in Game of Life to be able to load unsigned code into the Game of Life game console. It was absolutely insane, and they did this in the course of just like 24-hour crazy straight sprint on probably never having seen Game of Life as a computing platform before to creating hardware mod chips in it. And so, in continuing in that fashion, now that having introduced teams to Game of Life, we created this Game of Life challenge for finals. Other kind of esoteric machines that have been seen in finals, there was a DEF CON CTF year where every challenge ran on this custom architecture created from scratch just for the CTF. This was in the run by the organizers before us, Legitimate Business Syndicate, and they basically from scratch created an entire type of CPU that had bytes that were 9 bits long. It stored data, packed it in what was called middle endian. It was a crazy architecture that the teams had to learn from scratch from the night before the competition and then hack in it, right? So the kind of core concept of CTF, reversing or otherwise, is how fast can you go from not knowing something at all to knowing it so well that you can find specific tiny corner cases and tiny ways, tiny strings you can pull to bend a program that wasn't intended to do something crazy to your will, to make it do something crazy. I often tell people that you take a program.
The essence of security, right, Jan?
Exactly. The essence of security is, it's a dance. You take something that was designed to walk and you teach it to dance.
As a world-class swing dancer, that really means something.
Thank you. Exactly. Those are kind of the two challenges that we can discuss, Rorschach and Casino Life. The third challenge, Parallel AF. Adam, do you want to mention at a high level that you didn't expect that it was quite this hard?
Nope. I don't want to say anything about it until it's over.
Adam's not going to say anything about it. So he wrote it. The teams have so far hammered it for 8 hours, and it has remained completely undefeated. So we're going to see what happens overnight. So the way that DEF CON CTF, for those that don't know, usually works is we start the game usually at 10 a.m. on Friday morning. All of the teams arrive, and teams arrive from all over the world, really all over the world, flying in from Taiwan, from China, from Japan, from Santa Barbara, California, like near and far. And they show up usually Wednesday, Thursday, try to get unjet lagged, show up on Friday to hack. Start Friday morning, we hack all day. Start Saturday morning, we hack all day or until the evening. Start Sunday morning, we hack until the closing ceremonies. This year, because of DEF CON Safe Mode, with all the teams being spread out around the world, we couldn't do that. So we had to, or we could have still done that, but then there would have been a significant portion of our teams that would have had nothing but night shifts for their hacking, and that's not fair. They would not have been able to perform at 100%. So instead, we created an insane system where we have shifts of 8 hours hacking, 9 hours rest, 8 hours hacking, 9 hours rest. And no one rests between the hacking. They all, I guarantee you right now, these teams are hitting all of these challenges very hard, trying to solve them overnight so that in the morning they can start, or morning, when the next shift starts, they can start firing exploits against each other. So it's a little made a little even worse by the crazy.
So what's the normal time frame schedule like? Like how long do we normally go and do it?
10 hours on Friday, 10 hours on Saturday, 4 hours on Sunday.
So 24 hours of total game time.
Of total game time.
So, and I have and so if you want to check all this information, so I'm streaming on, it's all public, so you can check all of this stuff out, our schedule here. So yeah, next shift is at 9 p.m. DEF CON time, or the setup's at 9 p.m. and then the game starts at 10 p.m. with a brutal 6 a.m. end time.
Yeah. So now the players can, of course, have. Usually, the players are not very kind to their bodies as they play. We've had people push themselves so hard that they passed out at their table and collapsed. Like, I was walking back toward the organizer podium, and I look over, and there's a hacker that is, hacking away, and then suddenly this hacker's head just like hits their keyboard,
Boom.
And then the person just falls to the floor. I mean, because they were hacking so hard, they forgot to eat, drink, sleep for way too long. So probably the same thing will happen again, but the twist now is if someone wants to catch the whole competition and doesn't want to stay up all night and so forth, they don't really have a choice anymore, which is very painful, but we'll soldier through this year. Yeah, so it's a really a crazy scenario. Adam, did the server for Lightbox successfully start?
Oh yeah, it did. You want to try talking to it? We have to upload a pattern. So what was that? Jan?
No, I was just gonna say you can show this is archive.000. You can go there right now, and play this previous iteration of this.
And I think since we're wrapping up, this goes into kind of both Jan and I's philosophy. We both, Jan literally started going to DEF CON when he was 14 and somehow tricked his parents to letting him go to DEF CON, and he didn't even have a hotel room, I believe, the first time they went to DEF CON.
I did, but Otto didn't.
And so, wandering around CTF, would you call yourself a noob then? I mean, I know you'd call yourself a noob now, but you were definitely a noob then.
Well, I was a massive noob. I back then the CTF had what was called a gray net. So the capture the flag wasn't as well defined as it is now. This was DEF CON 9, right? So it's almost 20 years ago.
You're old, man.
Yeah, it's pretty bad news. Back then, you could show up and plug into what was called the gray net. And the gray net was like, we have 16 teams this year. The gray net would have been team 17. And it was like a free-for-all. You had everyone plugging in, script kiddies, super pros, and et cetera. And I plug in to try to tell my friend, who's also now on Order of the Overflow, that, hey, I'm at DEF CON, it's so cool, and so on. And my AOL Instant Messenger session got sniffed.
Whoa. And
fairly soon, my friend, or actually my friend's friend, taps me on the shoulder and says, hey, are you Jan Shosh? I'm like, yeah. And it turns out that they were in the gray net area as well, and they were looking over the shoulder of the fucker that sniffed my AOL Instant Messenger session. And that's how they knew I was in that room, and they found me. Until then, we had only known each other online. It was amazing. Yeah, so that's how I first got into DEF CON. I thought, oh, these people are like the CTF hackers, like the people actually, you know, scoring points. They're gods. Now from the other side, I realize what news we all are. But it's a message I always try to convey to everyone curious and interested about CTF is, you know, there's absolutely guaranteed that you can do it if you put your mind to it.
Yep.
Especially, I mean, look, Adam is here. That should tell you.
I didn't go to, actually, Jan and I met at playing DEF CON quals in 2008, 2009 at UC Santa Barbara in 2009. Yeah. And that was, I think, my very first time going to Vegas for DEF CON. So it hasn't even been that long for me. So yeah, and honestly, I mean, the funny thing is running all this stuff, you know, and playing with these teams and everything, you know, I learned stuff today about tools and how to learn things. Like part of what we do as a group is help each other out when we're testing things or deving things, or, oh, did you know this? Or do you know there's this cool feature and this kind of stuff? So, I mean, the important thing is constantly learn, get better, and you definitely will improve your skills over time. And you can be one of these amazing hackers that are, you know, competing in CTFs, understanding these crazy, insane game of life systems, and yeah, nothing's beyond your reach.
Absolutely. Anyone got any questions about CTF, about how, whether it's philosophically in general or how the game progresses from here?
Yeah, it's hard for us to give specifics because we obviously don't want to give anything that could be even construed as a hint, but we would love to answer questions if we can.
Absolutely. We can also take text questions in discussion.
I already asked. I was going to say, just like your classes, I think people have fallen asleep, and so maybe it's time we...
Ooh. Yeah, we can totally wrap things up. Someone asked about pistachios in the discussion text.
Do you want to tell that story, or do you want to leave it as a mystery?
I'll say this. Who the fuck is Pistachio?
Fantastic.
All right, on that note, you can still ask last-minute questions if someone's late. We'll chat. Otherwise, day one is just the beginning. No challenges have been retired, so we can't really go in details. Tomorrow, and that is actually tomorrow, roughly this time, I think actually an hour later, or maybe this time, on Saturday.
Yeah, Saturday 1 p.m. we have the next scheduled public recap.
We're going to go in depth into some retired challenges. Hopefully there will be some retired challenges, and then we can
if these teams just started hacking, I think we could retire some challenges. But really, I mean, it's not up to us. They have to steal the flags, Jan. We just create the challenges.
Yeah. You can lead a hacker to the flags.
But you can't write their exploiting system and automated flag submission.
Exactly. The best thing is when you're looking at the logs and you just obviously see that someone wrote an awesome exploit and they're running it by hand instead of like scripting it to hit all the teams.
Well, it's easy. You just hit up and you go back a couple, Control B, so you can go a whole word, and then you change 1 to 2 to get team 2. You hit enter, flag, and then you copy and paste that in the interface, and then you go team 2.
Yeah, I've been there, done that.
We've all been there.
I had a whole year where our network analysis system. Oh, should we talk about stealth? We should talk about
that was the big thing you did this year.
Yeah, we had 1 year when we were playing where our whole network analysis system it wasn't even TCP dump. I mean, it was TCP dump to capture and then we grepped them. Just literally grep instead of actually parsing the packets. It was easier for a number of reasons. In CTF, you need an attack defense CTF where you're going up against really a kind of mano a mano against.
I'm now sharing my screen with the info there about the PCAPs. So,
awesome. Yeah, we're going up
against. So previously in the past, right? Previous years. So you get access to the data that people are sending to your service The idea of which being you can see when people steal your flags, so you can steal your exploits and launch their exploits and launch them back at them and at other teams. So you get this, you can see this really crazy behavior that happens where one team launches an exploit and then other teams steal it, and now exploits are flying and teams are patching, trying to fix those things. So in previous years, we said, let's get away from PCAPs. Let's limit the number of PCAPs, and we'll only release PCAPs after a certain number of flags have been stolen for that service.
Adam, can you go a little bit into the reasoning behind that?
Yeah, so the reasoning is, well, it comes back to, what do we want to get out of this game? Who do we want people to win this game? We want like Jan said earlier, the best hackers, the best, mobile hackers. If you drop these people into a desert island, would they be able to hack sand and coconuts and trees? And I think yes, based on how resourceful they are with these systems. So, we want it to be less about, I see that you stole my flag, because we actually had this system when we played DEF CON, is we would be able to, like Jan said, we were grepping for our own flags. When we saw them going out of our PCAPs, we were able to take that, actually just the PCAP, we'd drop it into a folder, and then we'd replay that network traffic against the other teams. And if they stole the flag, we would submit it, and we were able to actually get points and play the game without knowing anything about this service, how it worked, anything, right? So we really were standing on the poor backs of those reverse engineers and those vulnerability analysis people who did that time and that effort. And so we really wanted to switch the game less from network analysis and more to raw pwning, hacking, exploiting skills.
Yeah.
And so that's why we said, hey, we'll only release PCAPs when the service is close to being retired. And that was the big kind of change that we created.
So that was the change last year, or the year before last, when we took over hosting. And there was this comment that, it is a bit of a bummer to lose that aspect, right? Because, PCAPs would only come out when after so much time that there's not really much you can do on this challenge anymore, because everyone has patched it, everyone is exploiting it left and right. And so we went back to the drawing board, and we thought, how can you make this sort of network analysis challenging, useful, and kind of not just something that you can show up with a completed system and just turn it on, like we did so many years.
So then you only have to be slightly better than the best hacker, right?
Exactly.
Because you steal all their exploits, you do one of your own, and then bam, you're in first.
Yeah, and we had years where our exploit replay system was embarrassingly enough responsible for the majority of our points, right? So we came up with this stealth system where the inspiration for this was Phineas Fisher. If you haven't looked this up, Phineas Fisher is a hacker who hacked Hacking Team and leaked all of their data on the internet. It's a really fascinating write-up that they wrote about this process, right? And what really struck me, you can just search for it online. I have some of my slides from my various courses online, and there are links to this there, or you can just ping me. I'll send you a link to their write-up. Phineas Fisher, as part of the process of Hacking Team, did this hyper careful exfiltration of data to hide their presence, right? And this hyper careful exfiltration of data had a cost. The cost in that case was bandwidth, right? They couldn't exfiltrate tons and tons of data because that's noisy. So there's this trade-off in these sort of exploitation scenarios, often between stealth and just raw power or whatever, right? Raw effectiveness, short-term effectiveness. And we tried to capture that in the stealth system for DEF CON more explicitly than has been in the past. Every challenge has two endpoints. One of these endpoints, when you communicate with that challenge, you do not leak your network traffic to the victim team that you're exploiting, but any exploits you run are only worth half points, right? And so it takes you twice as long to achieve the same result, just as it took Phineas Fisher much longer to leak the data, and so on. and a lot of different examples. So this is the first year with this system. And so far, it's really interesting. We're seeing a very interesting mix of course, we see all the traffic, stealth traffic, non-stealth traffic. The
Can't hide from the order.
Exactly. It has been super interesting to watch, the type of traffic that, teams probe publicly and then they exploit stealthily, and sometimes the other way around, because sometimes the probes are what's
yeah, maybe you want to throw off people's analysis or whatever, so you want to force them to have more PCAPs to look at. So yeah, it's a really interesting dynamic that gets put in the player's mind of what do I actually do, which traffic do I make.
And the other awesome thing that we were excited about, it makes network analysis critically important, because you need to understand, should you stealth based on the state of what everyone else is doing as well.
Okay, so quick question, Jan. I think for the end, there's a good question in the CTF discussion text about essentially about the spirit, and I know I get this a lot. I'm sure you get this a lot. So how do I get started in CTF? So I've just been listening to Zardist. I am super stoked about CTF. I know some stuff. How do I get started?
Awesome. I'm glad you asked. So historically, I have told people just show up to CTFs, but this is a very painful process. But
it's important. Showing up is important. I mean, that's like
there's no way
literally a skill.
Absolutely. There's no way to avoid that, but there is a way to make it less painful initially. What I've seen is there are people that can show up to CTFs and just lose over and over and over and over for months, and then they start solving something and solving something and solving something more, and then they get rolling, right? There are people like that, but the majority of really potentially talented hackers get discouraged through this process. So Adam and I are both professors at Arizona State University, and we thought about this problem a lot, because undergrads come to us and are like, how can I hack? How can I hack? And we tell them, okay, join ASU's CTF team and hack with us. But people get discouraged. So we have a number of resources at ASU. I'll talk about one right now, and it is called pwn.college. Let me bring it up on the stream.
I can do it on mine. Or you got it?
Oh, yeah, go for it. Do you have a Pwn College account?
I think I hacked one earlier. No, I actually don't. Make something up.
All right, so I brought up pwn.college. As you can see, we really like this hacker theme. Pwn College is an educational framework for cybersecurity, and specifically the type of cybersecurity that is very easy to approach in terms of moving into CTF, binary analysis, which I love. Might not be the easiest thing. So this is the course I teach undergrads, and I took a completely established course at ASU. I threw it out, and I remade it from scratch to be a CTF course. I created a bunch of different individual modules that students who have zero knowledge, people coming into this course, typically don't even know how to use Linux on the command line, and that's fine because we have a module that requires you to use Linux on the command line. There's a bunch of modules, and these modules have documentation, slides, and before next semester, I'll have videos up. That's my plan for losing sleep after DEF CON. But let me show you the challenges, which is the heart of the system. So we go to ctf.pwn.college here. You can click register or log in. And it shows you the challenges. These challenges are for the various modules. You say, okay, I'm interested in learning how to abuse setuid binaries, or I'm interested in learning how to escape jails. You know, like simple
Not like a real jail. You have to go to the lockpicking village for that.
Exactly, which I highly recommend. But you can do lockpicking, whatever, software jails. how to write shellcode, how to write like how to reverse engineer binaries to write key generators, et cetera, et cetera. And we say, okay, well, here's like the set UID challenge, and then you choose a challenge. Set UID is special because basically these are all the various utilities in Linux, and you have to use them to leak out a flag. And we can actually let's leave that as an exercise for the reader. What's a nice easy one? We will do like one of the shell coding challenges. So here's a bunch of challenges, right? The idea is practice makes perfect. So you can go from 0 to hero step by step by step. And the other idea is these challenges will teach you how to solve them. So you click this teaching challenge. There's 23 solves platform-wise, and you can do this right now. And you say, okay, let's practice doing this challenge. You click here. It waits and say, okay, hey, you can now SSH in. You can set a private key in the config, or you can just click terminal right here. And it'll actually take you right to a terminal where you can start interacting with the chat. And here is the challenge dropped into a running Linux box that you're SSH into through your browser.
I don't know if it's just me, but I can't hear you.
Yeah, it's really tricky to handle this text push to talk along with the router. So anyways, this teaching challenge explains what you're trying to do, explains where memory is mapped, et cetera, reads in input, and then you can.
Again, can't hear you.
Yeah, he's got a baby at home, so there may be he's deliberately not pushing to talk. But so you can kind of read the screen a little bit. So it's telling you that it's mapped. What?
That
So
was a
reading
problem. I hit F.
Man, are you messing with Pulse Audio again? Everyone knows you
Don't
never
worry,
mess with
don't
Pulse
worry
Audio.
about it. You're back. You're back. All right. Anyways, so this teaching challenge will tell you all about the constraints, so you don't have to reverse engineer it, and then it'll ask you for shellcode. And it lost connection, but let me show you what happens when I get my connection back and then enter some shellcode. So I just hand type some x86 assembly. Obviously, it's meaningless. And it disassembles your assembly and tells you this is what you input. And then it'll run it and tells you, hey, you crashed. The awesome thing in practice mode, I can debug it.
Pushes.
Yeah, that's because that's capital P, so you can remember that. If you want me to write other stuff, I don't remember.
Is this the meaning of the name PPP? It's just push RAX, push RAX, push RAX?
The awesome thing, of course, it's a CTF challenge. You need to cap a flag. So let me cap the flag because I'm in practice mode. I can actually see what the flag is. So then when I debug this challenge and step through it, I can figure out that it's working or not. Right, so this is a practice flag of all zeros. So then for some challenges, like the reversing challenges that read in the flag and then do crazy stuff on that, you can actually single step through them in a debugger in practice mode, and then you can't do that in real mode because there is no pseudo. You have to actually solve the challenge. But it's the same challenge, so you can practice your exploit, figure out what's wrong with it, debug it, and then run it. I'll show one more thing. We partnered with a company called Vector 35 to give everyone a binary reverse engineering tool that they could use to actually look at these challenges. And I'll show you that right now.
Come on, man. You don't know how to do pop-ups correctly?
Hey, it's not me. It's I blame my student.
What is this, the 90s?
Anyway,
Click a button and then the pop-up blocker that never runs has to stop it?
exactly. You click that, and it'll open it up. I don't have a Binary Ninja account at the moment here. And it'll open it up in Binary Ninja, which is like, IDA Pro, which is kind of the standard tool for reverse engineering. But it works in your browser. So as you can see, you can do all of this in your browser. Honestly, I didn't mean to go on a sales pitch of this. I was just really excited about the platform. And Adam brought up, how do you get into CTF? This is one way, right? Look at the slides. Watch those lectures. They'll go online in a couple of weeks. And then
the other important thing that you mentioned, is, I think it's really important to do a combination of things, right? Like Jan said, show up to CTFs. Find a group. If you don't have a group, find a CTF group. There's a CTF team called Open to All, which is literally open to everyone. I mean, find a group, go to CTFs, be lost, be okay being lost. Jan and I were those people sitting in that room at CTF looking at a challenge going, I have no effing idea how I could possibly solve this. But you try and you try and you try for 8 hours and you probably fail, and failure's okay. And then the really important thing is to always go back and learn, how did people solve those challenges? There's a great community of CTF write-ups and the problem with CTF's write-ups is they don't show you all of the head banging that the author had to do against the wall in order to solve the challenge. They show you the beautiful golden path that gets you the flag. So it's important to keep that in mind, but learn from those write-ups. And then at the same time, while you're competing in CTFs, do these kind of training activities. There's pwnable.kr. There's a lot of really good over-the-wire type resources that are amazing. Jan's going to put up his war game in that browser there. So he has, if you go to github.com/zardis/wargame-nexus, it's a list of all these different types of CTF challenges and all the different categories. You want to get better at web, you want to get better at binaries, you want to get better at reversing, you can go here. And really, honestly, it's on you. You have to, if you put in the time and the effort, I guarantee you will be a good CTF player and a good pwner, exploiter, reverser, whatever you want to be. So yeah, take advantage of those opportunities for sure.
Absolutely. Adam and I, our mission with everything, with DEF CON, et cetera, has a strong educational component. So if you're interested about learning about this stuff, and we do other stuff, we do academic research into cybersecurity. I'm one of the founders of a binary analysis engine called Anger. If you're interested in any of these concepts, just contact us, ask us a question. We're pretty friendly.
I guess we'll be on the Discord now.
On the Discord now. All right. Come see us tomorrow for our sync up, our recap at 1 p.m. And otherwise,
wait, don't the
go ahead.
Don't the kids say like and subscribe? Isn't there some way they can give us social capital or money or something? Yeah, I think it's here maybe, or I don't know, Discord. Maybe it's...
Just say thanks at whatever, and some random bot will give you rep. I think you can trade in the rep for like food or something, maybe.
Yeah. How about this? You can just get us a beer at the next DEF CON.
Exactly. Exactly. All right. Feel free to reach out with questions. Otherwise, if you're playing the game, keep playing. Otherwise, see you at the next sync up.
Hi, I have a question.
Yeah.
What do you think of starting CTF, learning CTF and reverse engineering by first learning assembly and not just digging into like, what do you think should be like learned first, assembly or without the knowledge of assembly, starting doing reverse engineering and getting along? Thanks.
That's a great question. Yeah, you probably have I'd say both at one. I mean, I'm more of like a choose your own, whatever. Honestly, I mean, a lot of this stuff is interest. So if you find yourself reversing binaries for hours, it probably means you like reverse engineering and you're going to be good at it eventually. And then, once you learn one assembly language, it's actually pretty easy to pick up another one and understand what's going on ARM or MIPS or whatever. I mean, it's just different ways of thinking. So in my mind, it's like, it's nice to have a base of knowledge so you know what you're looking at and you know what the tools are, you know how to use object dump. It's nice if you're able to write an assembly program to do something, but then doing both, I think, is really good. Like, improving your reverse engineering skills by looking at binaries. Yeah, I don't know. What do you think, Jan?
So I actually think I'm going to take the opportunity to answer a slightly different question. I think all of computer science should start from the lower level up. Right now we teach kids Python first, or Java, even worse, right, first, and so forth. I think it would be much more helpful to start with logic gates and build up on solid principles the understanding of what a computer is. And then
you could start from the game of life.
Boom. And then you can really go in depth into hacking right away, into reverse engineering, because you've just done the whole, process from logic gates up, and then you can kind of go back down. So from that perspective, I would say learning assembly and then applying it is great. I'll give a caveat. My class where I learned assembly, I went to Rensselaer Polytechnic Institute for undergrad. They back then, CTF.
Do they even do security there? Are you so old? That was before security.
I think RIT has a security class. No, so RPISec's actually now competing in DEF CON with, they're one of the teams. Let's see what place they were at.
A place, top 16, I think.
Top 16. So right now RPISec is in like 10th place, but they're hanging in there. At RPI, the computer organization class, which is what you typically take as a sophomore, was basically x86 assembly and then hacking, reverse engineering, etc. And x86 assembly was almost an excuse to get to the hacking. And that, for me, was the perfect way to learn x86 assembly. I learned it through hacking challenges. I mean, sure, there was like one homework assignment where it's like, write a function. And then it's like, okay, now here is a binary bomb, reverse engineer it to figure out an input to defuse it. That was awesome. So I would recommend trying to do something very similar. I'll do another sales pitch plug. A group of RPISec alumni, RPI alumni, I was never in RPISec, it didn't exist back when I was in college, but a group of fellow RPI alumni founded a platform called War Games, which lets you, again, in your browser, get familiar with assembly and reverse engineering and even exploitation. Look it up. The company is Red 2 Systems. The platform is War Games.
Yeah, and I think they, I don't know. A lot of this stuff is transferable. I think it's like programming languages a lot of the time is like, you get really good in one language and you can go into another language and write, throw down code there because it's not because that language. It's because like when we're debugging one of our team members' crazy Ruby code, and I haven't written Ruby code in over a decade. And it's like, I can kind of read it and then I can Google for how do I do a list in Ruby. And the other thing actually that I've found, I don't know if Jan has found this, but there is a lot of truth to this adage of like, you really don't understand something until you have to teach it. And so like my actually background in CTFs was all web security stuff. But when I became a professor and I started teaching how to do binary exploitation, that made me understand it at such a deep level that now I really have a much, much, much better handle on it than I ever had. So you can even apply that in like a CTF context, right? If you have a CTF team, organize regular meetings and be the person that presents, go through the latest, God, I hate all those, the house of whatever heap exploits, or even start small at whatever level makes sense. But like, break a problem down. When you really start looking at it and say, how do I explain this to somebody else? You really have to understand it.
Yeah, and I'll elaborate on this house of whatever. So there's a class of exploits, like a whole genre of exploitation called heap
techniques, right?
Heap techniques, yeah. So by misusing or causing a program to misuse dynamic allocators, you can do crazy stuff, right? And achieve execution and so forth. And then this used to be just like a completely opaque magic to me and to my teammates back when I was hacking with Shellfish before we decided to host this CTF with Order of the Overflow. And back then, we created something. We had a hacking meeting in Santa Barbara, and then we created an offshoot. And we said, this is going to be the heap exploitation meetings. And we just took turns teaching each other various heap exploitation techniques. And to teach it through that process, none of us knew them. Through that process, we learned them well enough that Shellfish's how to heap repository is like a de facto source of knowledge for heap exploitation nowadays. I absolutely support. I would generalize it. If you really want to learn something in a very deep level, go one step beyond. Whether that step is not just learning but teaching, or whether that step is learning something that depends on what you wanted to learn. So, like you said, reverse engineering. If you push through and become a good reverse engineer, you will understand assembly, for sure.
Yeah, that's there's no way.
So things that kind of are dry and boring on their own, like the inner workings of a dynamic allocator, suddenly might become very exciting in a different context as a base for something.
And then it helps you, I feel like, in learning a new weird system, right? So there's a new weird, maybe it's a different allocation system, maybe it's something else, but you've studied a system to understand what kind of primitives it allows you to do, those types of things that you can apply that mindset to this new domain.
Yeah, absolutely. I'm
cool.
Looking.
All right, we got to get back to CTF adminning.
Yeah, all right. Sorry to keep cut this short, but we're here. Feel free to just PM us at any point, or you can, of course, also shoot us an email. Our contact info is quite public. Look up overflow.io, and then there's a team list there. Ping us on Discord. Drop into the next recap. And hope to see those of you who aren't hacking in our CTF this year, hacking in our CTF in the future.
Especially if somebody else is hosting.
Exactly. Exactly. All right. Ciao. Bye, everybody.
Bye.